When you buy the Melt Profiler 7, you'll get these components. You'll get a nozzle sensor, you'll get a sensor for the hopper, you'll get the Melt Profiler unit with all the cables, which includes alarm relays. Here you can see the TempSense ecosystem. We can monitor your melt through the nozzle, the hopper, in-cavity sensor, or water temperature. We offer step-by-step instructions on how to install the hopper sensor. So what we have here is a TempSense nozzle thermocouple. It's our special body, high pressure, high temperature. We have a thread geometry here and a female geometry to match that has the hole through to the board. Very simply, take your Never-Seez, put it on your thread as such, and then take this and thread it in. You're going to do this after it's already installed, and then take a wrench and just give it a little nudge, and you're good. Sensors are placed on one of the flats of a nozzle body, as you can see in this photograph. Installing the files. You should receive two different folders for installation. One is Melt Profiler version 0.08 and the other one is 0.09. 0.0, the difference between 0.8 and 0.9 is the alarm settings and how the alarm settings works. However, the setup files and the install files are housed within the folder in the 08. So you'll see an Instacal and a Melt Profiler, along with information that has to do with the enclosure and an actual setup guide there as well in written form. If you open up the 08 installation CD, you'll see a setup exe. This is the executable file that sets up the program, registers all the DLL files and the ID files. This has to be installed first. Once that is installed, then you're to go and install Instacal. Instacal is installed here through this setup exe file here. Instacal is the program that recognizes the board and calibrates the board for the first time. Once those files are installed, then you can go and move this file to a folder and take this TempTech Melt Profiler MC exe file here that we see and move that to your desktop. This is version 09. Version 09 has a different alarm setting in that once the alarm is triggered, it triggers a normally open relay to closed position. It stays closed until the next cycle starts. Version 08 stays closed for a period of time that you can set between 3 and 20 seconds. That's the difference between the two files. Both files should be installed on the laptop or the PC that you're using, and at that point then we're ready to run. Okay, now we're going to start the Melt Profiler 7 program up. It's been installed. Just getting ready to run production. When you first turn it on, you're going to see template not found. templates are something that you set afterwards once you find the perfect thermal quote template for the part that you're molding. So here we go. We got live numbers now. So first thing we want to do is go to settings, and we want to put a part number in. I put this part number in for today a little bit ago. You can set up your folder that you want to put it into, and this might be your mold or your part number you're running for that day. So the other thing you want to do is what kind of units you want to look at. The thermocouple type, sample to average, is a math model that's used to store the data. So 50 is a good number to use there. And then over here is the alarm output. These are your alarm thresholds where you can set a specific alarm. So in this case we have sensor number 5, so we will be adjusting these numbers once we learn what good numbers are. And at this point, this is version 08, so we're able to set the alarm active signal between 0.1 and 20 seconds, so we'll set it at 20 seconds. This means that we have a normally open relay. When the alarm is tripped, then you can it closes the relay, and then you can keep the relay closed for up to 20 seconds. So in order to gather up statistics, we're going to have to start production. When we start production, then you can see it will change the cycle count. Right now it's throwing data in there, but we don't have a stable process, and we just started, so these numbers really are meaningless. So we will start production, sets us back to that page, we say OK, and so now we'll start recording data, and then we can look at the data statistically. That data will then allow us to set the alarms based on making good parts. So you can see what we're seeing here is the real-time data that's coming off of the press. This, of course, is the injection portion, screw recovery portion, and now we're in an idle state. So these cycles then can be seen. If we hit the trending button, we'll be able to see multiple cycles on one screen. We've been up to speed for a while, so in a cycle or two, we'll go ahead and start measuring the parts and verifying that we have good stable parts. If we take a glance at statistics, we can see some numbers based on just 2 cycles. So that's not significant yet, so we'll run a few more cycles and we'll see what we end up getting. So if we look here at our statistics page, we can see 736.59 minimum and 737.15 max. 1 degree different here. The power factor, which is the data underneath the total curve, and viscosity rise interval is the number from injection start to max TE over time. So that interval is shown there. So keep our eye on these, and looks like we're pretty stable. The parts are checking out fine. So we might want to start writing these numbers down so that we can set the alarms over here. So we'll record this this data. So we want to look at the min-max 736.48, 737.15, 103.1, 117.2, 107.3, 112.1. So based on that data, then we want to set the alarm, so we can go to settings and go to sensor number 5, and we can put in let's say 740 and 735. Gives us a really narrow window, but we'll see what we can do with that. Upper PF is say 120, and lower is 100, and power factor constant is numbers, how much data we're actually collecting underneath the curve. That's written up in our manual. And then the upper VR is let's say 115, and the lower is 100. Let's go ahead and set these alarms. And okay, so I think we have the gist of how we would set up the alarms. Of course, you keep finding the high and low based on good part production, verification there. You would set the alarms. When the alarm is triggered, then you would control some other device that would, your device that would discriminate between good and bad parts. How you separate those. So we will stop production, and when we stop production, then it saves the data to CSV files in the folders that we designated. And when we exit the program, of course, the data is stored, and we can go back in and look at that data. And you can download the data. You can have it's all date stamped, so every shot that you see on this screen has been saved, and there's a specific date and time, as you can see down below here, and that's a reference to that particular shot. Of course, statistics tell us that the cycle count 15 on this particular date and time, so we can look at each cycle and get a thermal data numbers in our 3 variables for each part. Yes, we are. Take a look at the data. We would go to the folder where we save the data, and you're going to see zip files. So this was the last data set that we ran. I'm going to open this up, and we're going to see this type of report here, right? So because we recorded the trending report, we're going to be able to open up this trending file and see all of these jobs put on one big file folder. Then we can go in individually and look at each one of those. This also gives us the production run report. So this tells us how we had the data set. Take a look at time start. So these were our data points that we had set the alarm points, okay, for that production run. Then we can go to our trending report. And the trending report then shows us the data set here. And these are the individual files. So we start at 0. We work our way down. And you see we have up to 37.86 cycle time, 37.656 cycle time, 37.86. Okay, so you see these are the individual cycles. So we're gonna, let's say we want to graph this stuff. I'm gonna take a look at the trending report. We would come down to the bottom of the list, gather this data up, and very nicely. Let's say we want to insert it into a line chart. Like this. That looks a little fuzzy. We probably want to change the graph. Look like that. And now here we have the chart for all the cycles. So if we want to take a look then and say, oh man, what happened here? This looks a little weird. You're going to go here and look at that point, and it's point number 3190, and the value is 725. So if you look at 725, and then you would look at, say, a normal one, 726. So you got like 1 degree difference. That's really nothing to worry about, folks. It just means that I think we can set our alarms pretty broad and still make a good part. Individually, then you can go into any one of these specific files and take a look at that data and basically do the same thing that we just did and pull up the one graph, and you can say this is exactly what our thermal template was like for that part where we know we made a good part. Use this for product verification, for example. And here's our individual template. So if this is a good part, and this is typical thermal template that we have, then we would perhaps want to save this as a as our quote, our template for the when Melt Profiler is running.